Good afternoon, everyone, and welcome to our PTV Talks session for today. Today, we have a presentation from PTV expert Sean Fitzgerald and Levi Button on the integration of PTV Vissim and PTV Viswalk. Just a couple of items before we get started. Our next PTV Talk session is PTV Vissim on May 9th, which is the rescheduled one, and PTV Bistro on May 17th. This is going to be on a Wednesday, not a Thursday. There will be one email for the PTV Visum and the other PTV Bistro. Those will be emailed separately to register. If you're interested, please join one of our next web-based training courses. We have PTV Visum Managed Lanes training on May 10th and Visum Dynamic Assignment on May 11th. You can find more information about these trainings, pricing, and registration at PTV Group under Events and Training. At the end of this session, we have a Q&A as always. You can enter your questions in the question box at any time throughout the presentation, and we will answer as many as possible during our live Q&A session. And this session will be a little bit different. We have a few poll questions today that will be asked throughout the webinar. They will only take a moment of your time, and we appreciate your participation. And now for the first poll question. Have you worked with PTV Viswalk or pedestrians in your simulation models? And I am going to close the poll now. Thank you so much for participating. And now I'm going to pass the baton and the presentation will start.
Can you hear me?
Yes.
All right. I'm the very last of that sentence broke up, but I assume you said pass it over to me.
Yes.
Thank you very much. I'm gonna try and remember to ask the other two poll questions. So if I get about halfway through and it doesn't seem like I remember, feel free to break in. May the 4th to everyone. Today is going to be a little bit different from my normal talks and from Levi's normal talks. Normally, we like to show something new or interesting or unique or fancy or cool that we're working on or something, some new feature. But today, I just want to get a little down and dirty, especially since there's so much going on about just the everyday usage of tools that I get a surprising amount of questions on. I am Sean Fitzgerel, and I had the Mobility Viswalk Vissim business team for North America, and I'm joined by the Master of Training, Levi Button, who actually his presentation next week is going to be super fascinating. You may have remembered I did a airport model in the past. That was kind of more of a huge production kind of fantasy model, whereas his is more what you get out of a demo model that teaches you the literal and most advanced ways to do things in reality in a simple and more straightforward way for those who are getting started. Where mine may have overwhelmed you, his is much more informative to the literal get started towards airport modeling, curbside modeling, and it'll be really fascinating. All right. So I see from the poll that most people don't pedestrian model. So I'm very glad that I have this intro. I have this intro for every Viswalk presentation that I give to some way or another. You may say, I already use pedestrians in Vissim. I mean, but do you? the famous way of doing it is having pedestrians as a class, and there is a footpath vehicular model that's used traditionally in microsimulation modeling that gets close to what a pedestrian might be. But if you actually looked down into it, it's not actually a pedestrian model. It's approximating the movement of people in the forward motion using the Viderman following model. Just allowing more collision and a little bit more elasticity. Whereas VisWalk itself actually uses what we call a social force model, which was developed at the University of Karlsruhe with our team, just like all the other stuff, as a separate component of VisWalk. And the way that it works is I like to look at it like a magnet, or I guess if you have the force, you could use it like Yoda. But there are two forces. You have your isotropic and your anisotropic force. And those are just fancy words for how much do you want to get somewhere, your isotropic force, your attraction to something, whereas your anisotropic force is your repulsion to something, whether it be running straight into a wall or coming too close to a person or too close to a corner, or these kind of things, which you can flex through calibration processes. And we've utilized these in a lot of different scenarios, anywhere from simulating crush capacity in cars in Asia, all the way to simulating the 2-meter social distancing during the pandemic in a lot of social facilities. Another question I get a lot is, don't I have VisWalk already? I mean, if you take a look at Vissim and you ask it as an add-on, how do I get it? How do I bolt it into my software? But wait, aren't I already using it? If I open somebody else's model, it doesn't say VisWalk not enabled. I mean, you might have noticed it right there, down there in the corner. VisWalk was originally developed as an add-on to Vissim, but as a software functionality standpoint, they are married in functionality in the way that they are in the same GUI. Where you got to look here is in your license file here. I'm guessing that most of that 61% of you, and probably another 20% beyond that, your number there says 30. And 30 is the default in Vissim that says you don't have VisWalk. I know that's super confusing, but the reason that's in there is both to show functionality and to allow the building of functionality and sharing functionality between models without having 1,000 different versions of Vissim and bolting it on. And did I do it correctly? Did I export it to a different software correctly? That all of that stuff is unnecessary. It's already in there. What you're buying is access to populating your model with pedestrians. And another question I get on that is, what does that number mean? That number means the number of pedestrians you see in your model at any one time. If you have 1,000 pedestrian license and you're doing a model of 4 weeks with millions of pedestrians, but you only have 50 at a time, that still falls under the 1,000 license. But if you're doing a stadium with 80 or 100,000 people, you're probably going to want 1 million, maybe if you're doing the Olympics or something, it's at one time. So as soon as you purchase the VisWalk add-on, you'll get a reflective in your license. It's just a quick update, but you can go ahead and try and build your areas and replicate things quite a bit. Moving on my presentation, I'm having a lot of technical difficulties today, so I'm gonna see if this video plays. It plays! At least I see it playing. Here's a little tip and trick for y'all. You can actually turn on the components that you want to see and only see. So if you're doing a VisWalk only model, you can turn off all vehicular components. If you're doing a Vissim model, you can turn off all your VisWalk components, and vice versa, however you need. That kind of makes model building a little bit easier. And I don't know about you, but anything that makes my life easier and doesn't replicate and doesn't make me get confused, I'm all about. So let's move on. we need to have a little talk about crosswalks. I think anyone who's ever used Vissim may be familiar with this picture. This is what we call the classic view of pedestrian modeling in a Vissim model. There's nothing technically functionally wrong with this model. It's just so 1990s, early 2000s. And the way I like to think about it, let me see if I can get to the next slide here. When you think of a city, what are humans? You know, the traditional component of using pedestrians with vehicular following models just isn't reality anymore. Cities are more vibrant, people move within each other, they use the micro capacity of the system. There's a lot of error in their movement together. So let's bring the software over here a little bit. Tiffany, can you confirm that you can see the Vissim now?
Yes.
Okay, been having technical issues. So here on the right here, you have your traditional model. Makes perfect sense. You have your pedestrian inputs, you have your walking ways, but these are actually vehicular links. And when you get in here, you do have this footpath, no interaction. But here in this no interaction, what that does is it's deactivating the vehicular elasticity in the Viderman model to prevent collision, right? And that in its inherency means that pedestrianization in this way is simply a reflection of the highway capacity manual's idea of capacity of pedestrians, and not the realistic idea that think of it like particles within a limited space, right? They bounce off of each other. That can both be negative and positive depending on the situation. So a more realistic way of building a VisWalk model is like this. You have your waiting area for your curbside on each of the approaches, and here in your Vissim, if you click on your link here, you'll have this third component here called pedestrian area. And when you click this is pedestrian area, all of the vehicular components, well, most of the vehicular components related to the following model are deactivated. And it's from there on out, this link here functions more like a pedestrian area and less like a vehicular link. But at the same time, since it's a Vissim link, you're able to add in the conflict area between the vehicular and the pedestrian movement, which you can't get with an area. So this is actually a much better way of doing it. So, all right, fingers crossed. I'm going to push play here. All right. So I'm going to let these models run a little bit. I was gonna, make it a little bit more of a surprise, but would you believe that both of these models have the exact same amount of vehicles, the exact same pedestrian demand being produced at the exact same rate with the same destinations? But watching it over a few seconds, you immediately can tell that there's a major difference in the functioning of capacity and the function of the roadway, whether it's the green time for walking, or the amount of time for clearance, or the amount of friction between the points of the pedestrian entering the roadway to getting to the crosswalk, and everything in between. And then when you put it in 3D, you get an even better idea, right? This is what I'm talking about, that robotic thing here. When you're using the vehicular following model with with pedestrians, they just kind of walk like cars. Whereas if you come over here, this is the exact same demand, but using a realistic static demand, right? The people are walking to their destination. They're trying to avoid other pedestrians. They're trying to do things reasonable. They're reacting to the environment in a realistic way. But immediately we can see that if you're looking at a VISSIM model or a design, and this is the simplest design you can get, if you're looking at it in terms of pedestrian capacity, safety, the ability to measure elderly people crossing the walk, peoples with limited mobility, the realistic right turn factor versus the highway capacity right turn factor, the breakdown of lanes, signalization, and even advanced signalization, just something as simple as a crosswalk, you can see the major difference in using VisWalk for pedestrianization or using the quote unquote old way or the highway capacity or the synchro method for pedestrians. All right. So we're going to go back to listening to me drone on a little bit. All right. The curbside strikes back. Curbside means a lot to a lot of people. To some people, it's the end of your journey. To some people, it's the beginning of your journey. But to VISSIM and VISWALK, it's more like the transition of your journey. Let's see if this video plays. I'll give it a second. For anyone who came to the Detroit airport presentation, you'll recognize this. This is the point of the airport model where the cars are dropping off the pedestrians into the airport. This doesn't really look like a lot. Sorry. I need to turn off the auto on my thing. It may not look like a lot to somebody, but this is actually the transition point right here, where once the pedestrian enters that crosswalk, the waiting area exiting the bus stop, which in this case the bus stop is representing the drop off. Oh, come on, take a break. I apologize for my technical errors here. So that's basically the transition point between where a VISSIM model becomes a VisWalk model, and you can do vice versa with parking and with boarding and alighting of vehicles. Transit vehicles, the public transit vehicles. All right, it wants to go to the next one, so here we are. So asking yourself honestly, which one are you? Do you model your public transit like this on the left? You've got a bus representing the bus stop here. These are both perfectly okay VISSIM ways of representing it, but on the left here, you've got a bus stopping at a stop for just the amount of time for dropping off a pedestrian. Boarding and lighting based on formulas, and then moving on. It's a relevant capacity question, but I mean, is this more realistic? Oh, come on. So adding the VisWalk components, you have the extra components of the doors opening, people moving to the side to let the people off, right? The people queuing, waiting for the people to get off. But not only do they have to take into account getting off the bus, they have to take into account the friction of the environment, right? The environment to which they're coming. If there was a big bus stop here, there would be a walking capacity issue right here. So with VisWalk, you're able to integrate the VISSIM component of the capacity of the buses, which is kept from stop to stop. People boarding and lighting, controlling the numbers and that kind of stuff. So very few people actually do this the quote unquote correct way, and that's because if you look at this this slide here, I pulled this straight out of the VISSIM manual here on page 1005 under 4.2.22.2 quick start guide, and here's the map right here. All the stuff is built into VISSIM natively to be able to do this. And here we've got a bus stop, which I'm going to show you in just a second. So you should write this down, page 1005, because I have that written on a sticky note on my desktop so that I can find it for this map here of all the different components. But I'm going to show you the components because it's a lot easier. All right, so let's do this again. All right. So let's move it into our nerd view here. All right, here's the map I just showed you. And this is what I'm talking about a precipice or a boundary between the VISSIM and VISWALK models, because in order to get this integration, you need both the VISSIM and the VISWALK components, right? And they're natively built in. Because if you make a normal public transit stop, you just get the normal boring boarding data like that. However, here you can actually, if you come to this stop, if you create a new one, actually, let's just do that. And you click here, you've got all of these things built in right here to use with VisWalk down here. Add platform left, platform right. And when you add a platform right like that, it automatically creates the platform in the place that it needs to be to start the VisWalk model, right? And now you have this line here, edit PT stop, and you've got your more detailed public transit stop stuff, right? The doors and stuff need to kind of match in your vehicular component. I'm not going to talk about that right now because that's more of a VISSIM thing, but you can reach out to me if you want to talk about. You have to build the doors into the model by telling them where they are, but then you can come in here and tell them at each stop which doors are possible, right? So if it comes to like a stop that, so if you say that all the doors can be used and it comes to a stop on the right, it will only use the doors on the right. If you come to a stop that has both, they will distribute evenly based on their VisWalk destination, kind of. And you can build different waiting areas and different, but basically the boarding area, the picture here, this pink area, the door has to be somewhere within this area. Generally, stops are a lot bigger. You got late boarding. You can change compositions for different stops. You can have skipping possible if there's no pedestrians or no boarding or lighting. This is actually really interesting. I'm not really 100% sure, but the skipping possible, they will pull away if someone's running to the stop, but not close enough, which is actually kind of funny when you see in 3D. But you see there's a lot of cool components here. But these are all the components that are necessary. This is the simplest way to describe it. In my airport model, it did the same thing. You need to have a starting point and you need to have a platform edge. But within your platform, you need to have your waiting area. And this is one of the misunderstood things, is you need to have this waiting area within your platform area. It can be multiple ones. You can have 100 different waiting areas, but it has to be within. And when you create the platform, it will automatically set this information for you here on the second tab of your pedestrian area of platform edge, and set to the bus stop that it is here. This is also I've said it in every talk why I recommend naming your things, because it's really hard to come back and see bus stop 1, location 2, location 5. None of that stuff means anything. Platform edge, PT stop 1, bus stop 1 right. That makes a lot of sense in my presentation and my demonstration, but it doesn't make a whole lot of sense when you're coming back and doing reports and models and client presentations. So that's set automatically, but when you make your waiting area, you have to come in here and set the waiting area, because when you make a new area, it's going to be blank, right? So you have to set this in here. So when you're going in to the PT area, you have to set your destination to the waiting area. Right here, this red to blue. When you're coming off of the bus, you have to set it to the platform edge, not the waiting area. So the people getting on the bus go to the waiting area, and the people getting off the bus start at the platform. And then you have to tell them where they're going to go. Because if you don't tell them where they're going to go, they'll just disappear as soon as they get off the bus. So if you do it right, you should end up with something like this. This is dynamic, which means that every time that you add something, people will just function to that thing. I mean, all the components are already built in. Maybe it's better to show an example. Let's just throw this guy in here. The interesting thing is I don't think that the bus can see around the obstacles, so that's actually might affect the way that the bus stop functions. So then, all right, so now I've got these big 10-meter walls around. So now the bus stop functions like this, right? You've got it, oops, they missed the bus, right? So this is a good way to use VisWalk to stress test different designs super quickly. You can see that the people getting off the bus affect the people trying to get to the, see, he missed it, oops, because the demand is getting off. You would never capture that in formulaic, which is why we always recommend using VisWalk for public transit studies. All right, I'm gonna stop that there. Maybe that would be a good place, Tiffany, for question number 2.
Okay, question number 2 is, are you or do you have any projects that require more robust pedestrian simulation treatments or analysis? And thank you for your participation. Sean, I'll give it back to you now.
Awesome. I always like the idea that there's the necessity of more pedestrian modeling. It's becoming less and less frequent to come across people I haven't met in this field, but many people don't know. I actually was a VISSIM and a VISWALK user for my whole career. My specialty was early on, I did a lot of the pedestrian modeling when pedestrian modeling was hardly a thing. And, you know, all these airport models and train station models, and still it's not really much of a thing, but it should be. I mean, I remember working on the complete streets projects in New York and across Europe and stuff. People want pedestrianization, cycle modeling. We just at PTV wrote the guidance for modeling in the UK for pedestrian modeling, and we really support our customers with pedestrian modeling because it is the next big thing. And Viswalk is moving into an interesting world, especially with some of the MovePed things coming in the next couple of years out of Viswalk, with more fully articulated pedestrians and better behavioral models and more realistic queuing models. It's an exciting world. So let's move on. Rise of the attribute modifications. You may have recognized our master of training over there, Levi Button, has given a few presentations and a few UGM things on attribute modifications, but attribute modifications really do change the way that VISSIM and VISWALK work. People like me who have used the DLLs and the APIs and the Python and the Visual Basic scripts since the beginning of time, and they never quite work right. So the idea is scripting without scripting. We're building in functionality directly into VISSIM, directly into VISWalk to make the model better for our users. So this is an issue I came upon the other day. I wanted to make a very realistic representation of a taxi queue. I was kind of basing it off of the one at LaGuardia from when I lived in New York, where you wait at the head of the queue until you're assigned to a vehicle, right? It seems very easy. You know, I did a lot of the service point queue selection stuff in the airport modeling, and that stuff works really well. However, there's a bit of a timing problem with things like this, that VISSIM and VISWalk give you an exacting capability to be able to overcome. So this was our discussion area. For some reason, I've deleted my second text slide there, but so I had two ideas of how to really accomplish this. Those squares are areas, by the way, routing areas, the path of the pedestrians through the queuing tape. So the first idea was, well, maybe if I just make the waiting area, see that the dark black area is the waiting area for the transit stop. That's the one taxi is working as a transit stop. So I thought, maybe if I just make the waiting area really small, then only one person would wait in it. Oh, how I was wrong. In Viswalk, natively, there's not any kind of thing that says that the waiting area size has a lot to do with it. It's kind of a capacity analysis thing. So all I did was get a huge queue of people waiting in a semicircle to access the area that they couldn't get to, which, you know, didn't really work. So the second one I used was the service point selection, much like a queuing area, right? I wanted to say that the black area with the turquoise dot in it would only, you know, pedestrians would wait until that area was free. However, the thing that I didn't take into account with the way that VISSIM and VISWalk works is that the idea of the service point selection doesn't take, it's not like an IO gate for the usage of the area. And any pedestrian who went on to the next area, as long as the taxi was there, just jumped in the taxi with him. There was no gates. The waiting area was only for the public transit vehicle. So that means that as long as the public transit vehicle was still in the stop, the gate was open for more and more people to just tag along, even if they weren't invited. Big fail. So Levi actually taught me how to do this. So this is actually, come on. the preferred method that I worked out with him based on his advice. This is something, you know, we put, for some reason, all the attribute selections over here. You got your vehicle attributes here. You've got your pedestrian attributes here. However, what we did wasn't actually either one. It's right here, the global attribute modifications. It's the second to the last tab here under actions. You click on the attribute modifications, right? And I've got this guy right here. All right, so looking a little bit at our model. So what we wanted was we wanted that only one person would wait here and get on in the car. And they would only proceed to the queue head to wait to talk to the agent once that person got in the car and drove off. So what we did was we used all of the elements within attribute modifications as well as other elements within the model to kind of cheat this, right? So I don't know if you know this, but with a pedestrian model, you can set this tab here under behavior time distribution to anything you want, right? So here I've got gate holding time for an hour. There's this other tab down here too, which is kind of cool. I use this in the airport model. Waiting time is relative to simulation start. That means that the gate opening is, if it's an hour from the simulation start. So if someone arrives 20 seconds before the end, they don't wait for an hour, but that's not relevant to here. So I set the time distribution to an hour, and if you don't have a distribution, you come into your base data under distribution and time, right? So under here, down here, I have an hour. I mean, I guess I don't really need a time distribution. You can set a standard deviation. It really should be 0, but I'm not going to mess with it right now. So what happens is this, when a pedestrian enters this square here, it's basically they're held for an hour. However, through attribute modifications, I can edit Viswalk to act however I want, right? So this is kind of, I don't know, if you know SQL, it's very similar to SQL, but not exactly the same. So your construction element here, 1099, unfortunately I have to click out of this. So there you have your construction element 1099 platform edge PT, and then you have your 1091 here. Area is the waiting area, right? So if you open up here, you can see this formula affects this filter right here, this 1099. So if, and then here's your table, this is your SQL lookup. All your data is, I believe, the way that this functions through the Access Lite database. So when 1091, the waiting area of the pedestrian, has 0 pedestrians in it, then you need to set the right here dwell time target attribute up here in your upper right to 0. Else basically do nothing. So what happens is when you run your model, that right now, since nobody is here, this waiting time is 0. So let me see. You also should set your components of your model there so that they wait for people. But I was too lazy to do it. All right, so there you go. Wondering if we could go farther into the future and see people actually queuing. There we go. All right. See, and now they don't go to the queue head until the availability. It's important to set the capacity of the taxi, because if you do it by, I think the default for a single occupant vehicle is 2 people. See, that person was actually pushed out, so they came back. So yeah, so that's actually a really cool application of gating behavior, I like to call it, by using global attribute modifications. So let's just finish up with a little bit of a kind of a thought exercise towards what we're working towards with our integration. This is what we talked today. And you ask me, you say, that's great and all, but what if I want my city to look more like this? Because, you know, it's the 21st century and, you know, we don't want to look like global urban arterial. It's a cool little thing. Some people who saw new in 2022 might have seen this model in different contexts. This model is not meant for, this model is meant for the pedestrians to find their way around cars. It's not, this specific example isn't meant for people, cars stopping for people, but they will in emergency situations. This model is meant to show how you can get more flexible pedestrian movement. And so what this model was meant to show was for more complex urban areas, for like crosswalks and stuff. I don't know if anyone, you know, from New York or San Francisco or somewhere like that knows what I'm talking about in morning rush hour when everyone's queued through the crosswalks and thousands of pedestrians walk through the queue of people. So we've been working on that on this test model. Let me see if I can open it up. And for anyone that's been in the field long enough, definitely feels like Luke Skywalker right there. Okay. All right. So here you go. So basically, the idea of this model was, I'm going to slow it down a little bit. Was to show the ability of fine interaction between routing. You can see that the pedestrians are still ultimately attempting to find their most advantageous direction until they are presented with the idea of the car. In this case, they're trying to avoid getting hit. You see their behavior changes quite significantly once the vehicle is present. When the vehicle is not present, they walk more line of sight. But when the vehicle does enter their sight, they become more aware, and they try to find the gaps between the vehicles. And we've actually exploited a bit of a quirk here with the way that the interaction of VISSIM and VISWALK works. So what this is it's a pedestrian area link that has 66 lanes. And that might seem ridiculous, but the way that the interaction model works is that you can see that each little component of the lane acts as a vehicle to pedestrian conflict area. That may sound a bit pedantic, but for the overall way that VisWalk works, you can see that when no vehicles are present, they have free reign. But when the vehicle is present, they only are subjected to the conflict of that immediate small area of which allows them to find gaps between vehicles. This may not be an ideal situation for everyone, and this is actually something we've been working on as far as more advanced features in VISSIM and VISWalk. Not quite ready yet, but if you want to see something like this or you want a copy of this, just reach out to me or to someone, and I'll be happy to pass it on to you. And with that, I think I'll stop talking so much about VISSIM. I'm Sean Fitzgerel. I'm Senior Account Executive and Senior Subject Matter Expert for VISSIM, VISWalk, and Optima at PTV Mobility. And I'm joined with Levi, our excellent support manager. And if you have any questions, I promise I won't send Boba Fett after you.
So I think this will be the perfect time to do our last question. Would you like further information on adding more pedestrian/PTV Viswalk to your PTV Vissim license? Yes, no, and I'm not sure at the moment. And I am going to close the poll and we're going to start our Q&A session. Thank you so much for participating in our poll questions today.
All right, Sean. So we do have a few questions. I answered them directly to the person that submitted them already, but just these are some of the questions that came in that would be good for you to answer in total for the whole group. One big question I got was, can you just describe again what the benefits of upgrading to VisWalk module add-on or adding VisWalk to VISSIM from a license perspective? Because the question was, if we already have access to the physical components, what would be why would we need to get VisWalk? So if you could kind of touch on that again.
Right. Like I said, and I'm sure you mentioned, they're integrated from a technical component that separating them would be more tedious and pedantic than anything. Basically, what you're getting is the amount of pedestrians. Smaller agencies often use smaller amounts to great effect. Generally speaking, people hover around the 10K amount. Generally covers most big city projects. We do have clients in the theme park and the stadium industries that use million plus, but what you're buying is access to the pedestrian module. It's all still built into VISSIM, but you can't really do a whole lot of 30 pedestrians other than just get a flavor. So if you really want to take advantage of it, you need to unlock the pedestrian amounts.
Okay. Yeah, and that's more or less what I said as well. If you're kind of if your focus for the project is on vehicular traffic and you're just trying to get some conflicting flows and things like that, then you can kind of get away with using the vehicle pedestrians. But if you need to do any sort of pedestrian interactions with elevators, escalators, bus stops, things like that, you're not really going to get very far with 30 pedestrians. So,
I adding on to that, yeah, I mean the presentation I did on the first half of this presentation, if you missed it, you should go back, about the difference between the behavioral models can be a major difference in capacity equations depending on how you want. And of course, you should reach out to me or watch some of my previous presentations about evaluations using VisWalk. There's quite a bit of evaluation stuff in VisWalk, which is also quite useful for people who have pedestrian facilities. Sorry, Levi, go ahead.
No, that's good. Yeah, it definitely comes from when I'm discussing with potential customers or users. I usually come at it from like the perspective of, are you doing, you know, are you trying to retrain your evaluations around pedestrians or multimodal or something like that than shared spaces and things. Okay, so we had some questions about calibration parameters specifically. If we have time, we can circle back to those because they kind of get into the deep weeds with how to calibrate things. I did have a couple questions about the cost of VisWalk, particularly the idea that the cost of pedestrian modeling tools in general can be a barrier to entry, and at what point do the benefits kind of outweigh those costs, and how can we kind of work around that from a project planning perspective or something like that? So maybe you can get, since you come more from the since you have more on that, you know, consulting side, you have more experience on that consulting side, maybe you can kind of get into that, what kind of decision-making process goes into getting around those cost barrier of entries and things like that.
Sure. And like Levi said, before I joined PTV, I made the rounds in private and government consulting, and I have to say, the barrier of entry is a complex issue. I mean, moving towards our subscription model at PTV, I mean, you can get going with a really good VisWalk model for around $3,000 a year. Even if you have a perpetual license of VISSIM, you don't need to change to a subscription model to use a subscription of VisWalk. So you can grab it when you need it versus your normal maintenance cycle. We have lots of different availability, but I have to say, if you're on the private side, it's really more about, do you want to have that extra offering that delineates you from your competitors? I mean, if you're in New York City and there's the big 6 or the big 8 or the big 12 who are all going for the same projects, is that extra small investment going to give it to you? And from the government side, we have our VISSIM models packages include VisWalk, so that the government is able to support their private agencies towards getting more pedestrianization and supporting the green initiatives that most governments want at this point in history. Is that complete enough, or do you want me to go on?
No, I think that's good. I did have some questions about how do we deal with kind of those mixed use spaces? So we looked at how do pedestrians board and alight from vehicles and things like that, or pedestrian exclusive zones versus vehicular exclusion zones. And we saw some interactions at crosswalk level, but we frequently get questions, and we saw at least one question here about cyclists. So how do we deal with cyclists? Do we treat them as vehicles and use them as vehicle types? Do we treat them as pedestrians and use them as pedestrian types? So maybe you can elaborate on that a little bit more on under which circumstances would a cyclist be considered a pedestrian or be considered a vehicle, and stuff like that.
As far as the software is concerned, cyclists are a vehicle in VISSIM. So if you have VisWalk standalone, that would be just the walking and the wheelchair or other persons with mobility types. Anything cyclist, motorcycle and above would be in VISSIM. That being said, the cyclist behavioral following models and acceleration and deceleration models are all for cyclists specifically. They're not, it's not a vehicular model. So for those who don't have it, that's important to know. For those who do have it, stop using vehicle types for your cyclists.
And just to elaborate on that a little bit, we have done some projects with mixed use spaces where we did calibrate basically a pedestrian class using VisWalk pedestrians as cyclists. I did one project on the Brooklyn Bridge pedestrian deck where they were merging the bike path with the pedestrian paths for safety considerations and things like that. They wanted to see what the output. So there, if you really get into the weeds with the walking behaviors, you can crank down on those parameters enough to get a pedestrian class to act similar to a cyclist. It's not going to be perfect though, and you're going to need to do a lot of calibration and justification of the things that you use. So there is that. And kind of on that similar note, if you're thinking about like microtransit, like scooters and things like that, it'll be kind of similar considerations, right? So are they going fast in a straight line? Then vehicular types would probably be your best bet. If they're going slow and kind of weaving in and out of pedestrians and they're kind of acting more like just fast running pedestrians, if you will, you can get away with it. Just be very careful about how you calibrate those.
Yeah. And I find this presentation was meant to be more of this is the more literal way to do it. One of the beautiful things about our software and one of my specialties throughout my career is that our software, the way that it's open, the parameters, the way that they're open allows for intense customization. The only difference between what we're describing is that the model within VisWalk, the social model, is a 360 degrees four-dimensional behavioral model, if that makes sense, whereas the vehicular following models are linear, you know, like a cycle rolls forwards and backwards, which would be the only particular reason why we would say use the software for the vehicle of choice. But like Levi said, anything is possible through our customization parameters. I don't know if that made sense.
Yeah, I would say one last point on that is that the key difference is that vehicles have to run on links, and the VisWalk has to run on pedestrian areas. So making those mixed use kind of spaces, you kind of have to go with one or the other. Either pedestrian links acting as crosswalks, crossing against vehicular links, or you put everything onto a pedestrian area. And so you kind of have to go all in on one or the other, and that kind of will dictate what you want to do. Okay, so I think those are the kind of the broad questions. Again, we had some specific questions on calibration and things like that. If you have specific calibration questions, please send them our way. There are emails on the screen. They're a little bit in the weeds for our Q&A here. There was a question about how to get doors to open and things on buses. That's a little bit more complicated, but we would urge you to go check out our resources page. There was a presentation at our last user group meeting on new updates to VISSIM. You used to have to go through a third software called, what was it called? V3DM or something like that to open up to program doors and things. but now you should be able to do it directly in VISSIM 2023. So if you wanted to have doors open for good visualizations and stuff, then you can do that. Technically, the doors don't need to open, and the buses will function, and people just walk through the walls of the bus or whatever vehicle. All right, I think that's just about it for questions. So I don't know, Sean, if you had any last little comments or anything like that. Tiffany, can you confirm, do we send out the recording, or
Yes.
do we just post it to the website? I guess?
Both. It will
Both.
be on our YouTube, the American Technical Support Hub, and it gets a personal email when you attend or if you miss this webinar.
For those 44% who want further information, if you want something more, then the stuff we'll be sending out, my email address is right there. Give me an email and we'll chat, because I can literally talk about this for hours.
And if you have any other questions, feel free to email us at marketing.us@ptvgroup.com. And thank you for joining our sessions today. I hope you have a great day.
Thank you.
Thank you, everybody.
Thanks.